In this video, we're talking about how to solve a system of equations where maybe one of our equations is a quadratic equation. So we have the equations x squared plus y squared equals 9. This is a quadratic equation because we have second degree variables. So instead of just x to the first power or y to the first power, just x and y variables, we have an x squared and a y squared. In other words, a second degree equation, a quadratic equation. When that's the case, what you want to do is try to solve the linear equation for one of the variables and then plug that value or substitute that value into the quadratic equation. So here's what that looks like. This is our linear equation because we just have x to the first and y to the first, just plain old x and y variables. We want to go ahead and solve this equation for y. Y is already by itself. It doesn't have the coefficient of 2 that x has, so it might be easy to solve for y. What we want to do is subtract 2x from both sides. So subtract 2x from both sides, and when we do that, we'll get 2x minus 2x. Those will cancel over here on the left. We'll be left with negative y, and then on the right, we'll have 3 minus 2x. We want to solve for positive y, so we'll need to multiply both sides by negative 1. So if we multiply here by negative 1, we'll get negative 1 times a negative y gives us just a positive y. And then we'll flip both the signs on the right-hand side. So this is going to become negative 3 plus 2x. But it's nice to lead with a positive if we can. So we'll get 2x minus 3, because instead of a negative 2x, now we have a positive 2x. And instead of a positive 3, we now have a negative 3. Now, with this value for y in hand, we can take this value of y and plug it in right here for y into our quadratic equation. When we do that, we're going to get x squared plus, here's where we plug in our value for y. So we have 2x minus 3, so we'll say 2x minus 3. And according to our equation here, we're going to square that, so squared, and then equals 9. So we just made a substitution, we just plugged that in. Now we want to go ahead and simplify. So this is really x squared plus 2x minus 3 times 2x minus 3. We're just squaring the binomial, so we have to write two factors of this binomial, and I like to write them out because now it'll be easier for us to FOIL and make sure we get everything. So FOILing this out, 2x times 2x is a 4x squared. 2x times a negative 3 is a negative 6x. Negative 3 times 2x is a negative 6x. And negative 3 times a negative 3 is a positive 9. Now when we collect like terms, we get x squared plus 4x squared is a 5x squared. Negative 6x minus 6x is a negative 12x. And then we can go ahead and subtract 9 from both sides, because when we do that, we'll get the 9's over here to cancel. And over here on the right, we'll get 9 plus a negative 9, or 9 minus 9 is 0 on the right-hand side. So we just end up with 5x squared minus 12x is equal to 0. Now we can use zero theorem, because this is equal to 0 on the right-hand side, to factor the left-hand side and find solutions for x. So we'll factor out an x, and we'll get x times the quantity 5x minus 12 equals 0. And remember, zero theorem tells us that we have two factors here. One factor is x, and one factor is 5x minus 12. Because these factors are equal to 0, we know that at least one of the factors has to be 0 in order for this to be true. We can set each of them individually equal to 0, and we get x equals 0, this first factor here, or the second factor, 5x minus 12 equals 0. Adding 12 to both sides, we get 5x equals 12. Dividing both sides by 5, we get x is equal to 12 over 5. So now I have two possible solutions for x. I have x equals 0, and I have x equals 12 fifths, or x equals 12 over 5. I need to find the corresponding solutions for y, and I can do that by plugging these values into this equation I have here for y. So if we plug in x equals 0, we're going to get y equals 2. Remember, we're plugging into this equation right here. So 2 times x, or 2 times 0, minus 3, y is equal to 0 minus 3, or y is equal to negative 3. If I plug in x equals 12 fifths, I'm going to get y is equal to 2 times 12 over 5 minus 3. Distributing the 2, I'm going to get y is equal to 24 over 5 minus 3. If I find a common denominator, I have to multiply this 3 by 5 over 5. So I'm going to get y is equal to 24 over 5 minus 15 over 5, which is going to be y is equal to 9 over 5. Now I can say I have the solution points x equals 0 and y equals negative 3, so 0, negative 3, or x equals 12 fifths, y equals 9 fifths, so 12 fifths, 9 fifths, I should be able to plug both of these points into this linear equation here, 2x minus y equals 3, and get a true equation. So if I do that, if I plug in the point 0, negative 3 to this linear equation here, I have 2x minus y equals 3. So I'm going to get 2 times 0 when I plug in 0 for x, minus y, or minus negative 3, which is going to be a plus 3, is equal to 3. I'll get 0 plus 3 equals 3, or just 3 equals 3. So that's going to check out. This solution checks out in our linear equation. If I plug in this point here, 12 fifths, 9 fifths, I'm going to get 2 times x, or 2 times 12 fifths, minus y, or minus 9 fifths, is equal to 3. I'm going to have 24 over 5 minus 9 over 5 is equal to 3. Multiplying everything by 5 to get rid of the fractions, I'll get just 24 minus 9 equals 15. 24 minus 9 is 15, so I get 15 equals 15, and that checks out also. So now I know that both of these here are real solutions to this system of equations.